the best route to go? Like,
the definition of distance vector algorithm is, we can say, routing algorithm.
yeah, I mean, so link set and distance vector algorithm, they both do the same thing,
Mm.
but they end up at the result in a different way.
And in three-node case, it will be go to near leaf node or just finish, or go to near leaf node and from distance to the destination. And also many node case go to neighbors in cost and destination, distance to destination. There can be several options. And we should also think about cost change case. In bad news, it will be, thank you, it will be go to 4 to 100. Good news, it will go to 1. If it goes to 1, then it will affect to distance y to z. The cost to y to z will change to 1 for minimum. We are using minimum function, so it will just become 1. So good news will be reflected directly. But if it becomes infinite, 100, then it will be 100. Because minimum function use this one, so it will be updated. Wait a minute. If it become 100, then cyx is 3, and distance x to z is still 7.
Yes.
So it become dyz update to 10. Then based on dyz update to 10, pxz will update it again, 10 plus cx to y, which is 3. Then it will be updated to 13. Then it will be update, right?
Actually, it doesn't happen here because so so if y wants to go to z, sorry, so
X wants to go to z.
yeah, the issue is if x wants to go to z, it can just go here because this is so low, and it can just go right here because this is 2. Then it will be less than 7, which is the original. So this won't change. Like if this is 100, that doesn't change anything because this is already lower. So if you want to go from x to y to z, then like
x to z should be bigger than 7.
yeah. So actually like so, give me the like marker, right? So if you actually want to like change how this works, instead of changing the 4, you would change this to.
But in example, it changed this part.
Yeah, because in example this was 50.
Okay.
And this was changed to 60.
So if we should also able to count the table, x point of view, y point of view, z point of view. The x point of view, a minute, what is this? X point of view first table will be x, y, z. X to x, y, z. X to y, 0. So x to y, 1. X to z, 50. And here is infinite for y.
No.
They don't know y to z in different vector first form.
All right.
Yeah, it will be next one. So x, y, z, x, y, z, y to x, 1, y to z, 1, and infinite. And our consider this is not a, we will not consider link cost change situation.
No.
It will be complex. I don't think it will go that complex, right? I will just make a table. How many times they will or not know the information. In G table case, it will be they know x, y, z. G to x 50 and g to y 4. And it will be infinite. And next round is where remove this part. second one, extra advertise to Y and Z. So X, Y, Z, X, Y, Z. So, it is 150 thing. And Y let us know Y and G information, which is 4. So it will be updated 4. So actually it's updated in second round, right? But in textbook, it shows 1 second.
Yes.
And my question, I want to clarify one more thing is X is advertised by both G and Y, right? If there is G, if there is C, it will C's information will be updated to X next one, right? Because they have two distance.
That's a good question. I actually don't know.
Okay, this discussion. Thank you.
Because so the third table is for running the shortest path, because we're at this point, the only thing that would update would be like X's table and C's table and Y's table. So and then so this is X's table, right? So here X has these starting values, and then here or from the advertisements, X could find a new shorter route, so shortest path. So it could update this.
In third round.
Yeah, and so in third round they would be all synced. So they would all have the shortest routes possible.
Wait a minute. In third round, then there will be some changes happen.
I mean, if there are shorter routes,
X
there are not.
Y will be 1, but X to Z can be 5. It will be 5. Right?
That will happen here already.
Really?
Yes.
Because they already know here. And they got Y's information, so it should be updated. Here.
Yeah. But so if you do this next one, so then it's yeah. So for this one, it would still be 50, right? So for this table, it would still be 50.
Why is
Because it is advertised here as 50. So it would update to 5 in the third table.
Okay. Can you draw the full diagram here?
Yeah, sure. Wait, hold on. So yeah, so by X to Z, yeah, so it would be 50 and 4, 0, yeah. And they would know Y to X is 1, Y to Y
Yeah, right,
is 0,
because
Y to Z is 4.
for Y, they don't know it. This was infinite last time, right? And it's updated.
X to Y is 1, Z to X is... Yeah, because they just advertise it and they just add it to that table. But actually for Y, this table for Y, there's no new shortest route, so it doesn't need to update its own table at all. It already has the shortest route. So for here, it's so now here you do 1, 5, 1, 0, 4, and 5, 4, 0.
Actually, I can't understand that. Like, they got information of 50, but they also have information that it is 5.
No, they don't yet.
From Y's point of view, they have information of this one.
So X knows that the new shortest path is through Y, but Y doesn't know that X shortest path to Z is now 5.
But they know from X to Z is 5.
No, so So what happens here is we advertise this current state to everyone else, like before we do anything else, and then each node individually optimizes their link costs, and then it's all advertised here for the last time.
So our assumption is they don't calculate x to z. The y is
What?
y knows it from x to z. It can be 5.
Y doesn't calculate for x. Y only calculates for y. That's why x advertises 5 in the next one. So at this point, x advertises to y, and the each cost from to z is 50. Because here we go to here, so it's 50.
Well, I'm a bit confused, but we should go to the next problem.
Yeah, sure.